In this tutorial, I'll show you how you can perform a classification in R. Specifically, we're going to visualize our categorical response and look at its associations or relationships with multiple explanatory variables using the GG pairs function. We're also going to then perform classification using the caret package for logistic regression and k-nearest neighbors. As always, look out for the light bulb, the siren, and the check mark to get tips on what the code is doing, to let you know when you need to make an edit, and also when you can just run the code without changing anything. The first step is to load the classification packages, specifically caret and ggalley will allow us to visualize all of our variables at once. So I've already installed these packages, but for you, because they're new, highlight this and run. This will take probably a couple minutes for the packages to install on your computer. Notice that down here, it'll have a little stop sign. That stop sign is telling you that the packages are still loading, so just to be patient. Then once the packages install, you can run the library caret and library ggalley. This will tell R that you want to use functions in these specific libraries. The next step is to upload your dataset. So we're going to use the read.csv function and file.choose. Highlighting this line of code, you can open up a search window that will allow you to upload your dataset. Once you find your dataset, click OK, and you'll see that the mycls.data pops up into your environment window. It has 10,000 observations and 6 variables. The first variable in each one of your datasets is going to be called partition. This breaks the data into a training dataset and a test dataset that we'll talk about later when we want to break up our data into modeling our classification and then also testing how well it does on data it's never seen before. In this analysis, I'm going to try to predict whether or not a voter is undecided. That will be my categorical response variable. I'm going to use the variables age, education, female, and church in order to predict this value. In order to be able to easily reference these variables in new functions, I'm going to attach my dataset. So going down to attach my.cls.data, I can run this and it will mean that I will be able to use those names without referencing the dataset each time. In step 3, we're going to explore the relationships with a new type of plot, with the GG pairs. This allows us to quickly explore the relationships between multiple variables. Before we get started, make sure that you have this number of columns you need from your data. So here I have columns 2, 3, 4, and 5 referenced. That will be undecided, age, education, and female. Also want to include church, so I'm going to put in my last column of 6. I also need to make sure that my response doesn't say my response, but instead is my actual response name. In this case, that's undecided. So I'm going to change that code. Once I've changed those two things, I can open up my plot window bigger so that I can run this ggalley code. Once I click run, I'll notice that it'll take a little while for my plot to be created. That's fine, just be patient. Now we see a lot of things going on. Don't worry about anything other than our top row. These lower rows are all about the relationships between our explanatory variables. In this case, let's just take a look at this top row, which shows the relationship between undecided and all of the other explanatory variables in our dataset. The first thing I see is a bar chart of undecided. We can see that there's slight imbalance between our groups. We can see that there's fewer undecided voters than there are decided voters in this particular data set. We can also see that the colorization helps us make a distinction between groups of age, education, female, and church. Looking at the side-by-side box plots, there doesn't seem to be a huge difference in decided and undecided voters and their age. Looks like maybe the undecided voters have a slightly older age than the decided voters, but not by much. When we look at education, it does look like there's somewhat of a difference. Specifically, we see the median is a lot higher for the undecided voters than the decided voters. We also see that the variability is a lot wider for those who are decided than those who are undecided, meaning there's more consistency in the education of those who are undecided than those who are decided. Another thing we see are these mosaic plots. These are how the relationships between categorical variables are visualized. In the female group, we can see that there's a lot more females than there are males in this data set. We can also see that there's just a smaller proportion, it looks like, of those who are not female, so male and undecided, than those that are female and undecided, meaning there might be a relationship between female and undecided. It's a little harder to tell with this mosaic plot. If we look at the church mosaic plot, we can see that there are far more undecided people who don't go to church than there are of those who do go to church. We can see that among those who do go to church, most of those people are decided, which tells us that maybe church might influence people's political sureness. Looks like each one of these variables may have a relationship with whether or not somebody is decided or undecided in this example. When you use this plot for your report, I recommend that you just copy that first row of data and use that as your visualization tool. In step 4, we're going to partition our data and prepare it for classification. So the first step is to separate your data based upon the partition variable into a training data set and a test data set. You don't need to edit anything in this code, so highlight and run. Partitioning our data in predictive data mining is important because it allows us to build our model on the training data and then test our model on the test data. The next part you do need to edit. Right where it says my response, we're going to change this to your actual response variable name. In my case, that's undecided. So I'm going to put that here instead of my response. Once you put in your variable name, go ahead and highlight and run. This will be important in order for us to compare our predicted values to our actual values in our training and test data. The next step is to perform our logistic regression. The logistic regression function looks very similar to linear regression. We start with our response. This is going to be our categorical response undecided. Then we can add in our different variable names. So in this case, I'm going to start to type undecided. Then I'll put in my different variable names, starting with age, then education. Then I can add female and church. The rest of the code I don't need to change, but we can see now that these variables are being pulled from the training data set, that we're going to use the method generalized linear model, and it comes from the family binomial. This essentially is telling R to do a logistic regression analysis. We're going to call this output model-LR. Then we're going to use the summary command to see the table of coefficients. Go ahead and highlight all of this code and run. Looking at our console window, we're able to see the table of coefficients. We're also able to see that all of our variables are significant when the other variables are in the model. We can see the coefficients for log odds. Again, these are really weird to interpret on their own, so let's go ahead and interpret these as odds and percent change in odds. Coming back to our code, this is step 2 of part 2. You don't need to edit any of this code. You can just run it and interpret it. So highlight these 4 lines of code. And if we're looking down here, we can see the odds now. Basically, by using the exp command, I've back transformed the log odds to just be odds. So we can see now age of odds is 0.988, education 1.22 or so, female yes is 3.31, and church yes is 0.258. If we were to convert these into the percent change in odds, we can see that for age, this means that with each additional year, the odds someone is undecided will decrease by 1.1% on average. With each additional year in education, we can expect that the odds of being undecided will increase by 21.7%. If somebody is a female in comparison to a male, we'll expect that they are 231.4% more likely to be undecided than not undecided. And if somebody goes to church, then they are 79.4% less likely to be undecided versus somebody who doesn't go to church. So interpreting each one of these coefficients, we can see that it looks like the female group really makes a big difference on whether or not somebody is undecided in the election. Now let's go ahead and check out to see how our logistic regression model does at actually predicting our values. So we're going to calculate a confusion matrix, the accuracy rate, the sensitivity rate, and the specificity. In order to do this, we can use this confusion matrix function, but we first have to get our actual predicted values from the training data. So highlighting these first 4 lines, you don't need to change anything, but we can then see our overall output from our confusion matrix. Up here, we can see our confusion matrix. This is the actual values of no's, actual yeses. We can see that 4,210 no's were correctly predicted as no's. And we can see 1,972 of the yeses were correctly predicted as yeses. This gives an overall accuracy rating of 0.7728 or 77.28%. We can also see that the sensitivity rating is about 0.6119 and the specificity is 0.8813. There's a lot of numbers in here that are important, but these are the 3 main ones I want you to focus on in this class. So we can pull these directly from this output and put it in a nicer, cleaner table. So stats LR, I can just run these values and I'll see then all of my accuracy, sensitivity, and specificity right next to each other. This will allow me to easily compare between models. Now I can have a choice now to just leave my logistic regression as it is, or I can go up and change some of the values. You can simply just get rid of values that you don't think are necessary. Let's say I wanted to get rid of age in this particular logistic regression model. I could rerun the code again and see how accuracy ratings change. In this tutorial, I'll keep it as is. Let's go ahead and move on to k-nearest neighbors. In part 3, we do k-nearest neighbors. With k-nearest neighbors, we don't necessarily have a model, but instead we run an algorithm to see how many of the neighbors are going to best predict or classify our undecided voters. So the first thing we need to do is we need to build our model. Again, I'm going to put in my response variable and all the different variables. So here, I'm going to put in undecided for response. Then I can put in my explanatory variables age, and so on. Once I put in my variables, I again don't need to change anything. We can see that now instead of saying GLM and binomial, the method is KNN for k-nearest neighbors, and I have a pre-processing which centers and scales my data. This is the same as standardizing my bigger values. Then I'm going to use a tune length of 10. What this does is it tries 10 different k values for k-nearest neighbors. So from here, I can highlight all of this code and run. It's going to perform the KNN algorithm and it might take a few moments. Now I can see that the best value of k looks like it was 5 in this model. So that's the overall highest accuracy, 0.9341294 for accuracy. We can also see that over here in the accuracy rating that 5 is the highest and that after that the accuracy drastically starts to drop. So we're going to use 5 as our number of neighbors in our KNN method. We can now see how accurate our model is using the same sort of functions as we used for logistic regression. We can highlight this part of code and we'll get our confusion matrix and our stats again. Looking at the confusion matrix, it looks like of the no's, we correctly predicted 4,400 of them. Of the yeses, we correctly predicted 3,108. The overall accuracy of this model is 0.9385, which is really pretty high. Our sensitivity is 0.9643 and our specificity is 0.9211. This is a really strong model, and in comparison to the logistic regression one, we classified more values correctly. Let's go ahead and see what they look like in terms of just the stats. So now we can compare these across the board. All of them are in their 90s, which is really high accuracy. Based upon these two methods, I'm going to choose KNN as my best method versus logistic regression. A good way that I can compare these two models is by binding together my two stats. So If I were to run this line, I can see the accuracy, sensitivity, and specificity of my two models right next to each other. I can see that KNN is much higher in its accuracy at 94% or so versus the logistic regression, which is at 77%. Sensitivity is a lot higher, meaning I'm doing a better job of predicting those who are undecided versus those who are decided, which is what specificity shows. In all the cases, it looks like the KNN model does far better than the logistic regression. So I'm going to choose KNN as my best model overall. This is where you need to make a change. So in the best model or best method, I need to either put in model LR or model KNN. In my case, I'm using the KNN model. So I can just delete the rest of this and call my best method model KNN. Running that line of code, I've now signified that that's my overall best method. Now I can get a confusion matrix and a best-in-class accuracy, sensitivity, and specificity ratings for my test data to see how my model does on data it's never seen before. This is an unbiased estimate of how well this k-nearest neighbors does at predicting undecided voters. Go ahead and highlight these lines of code and run them together. Now you'll get to see your confusion matrix overall. You have, of the number of no's, you correctly predicted 1,112 of them, and of the yeses, this model correctly predicted 763. This tells us that our unbiased estimates for accuracy, sensitivity, and specificity are 0.94, 0.96, and 0.92, telling us that this KNN method does an awesome job of predicting undecided voters. Once you're finished, go ahead and save your R script so you can replicate things if you need to. Copy and paste your plots and output them to a document. That way you can write up your reports and share them with your group as well as your final report and presentation. Hopefully this video better helped you understand how to perform classification in R.